Right, guys, here we are. The part you've been finally waiting for, the Physics P3 of the higher tier June 2014 paper. Okay, we're gonna nail it down. We're gonna just completely get through it. You should have looked at the biology already. You should have looked at the chemistry already. Now we're gonna hit the physics. Okay. Not so much maths in this physics paper, but there's lots and lots of easy marks to pick up as well. Okay, so here we go. Look at the diagram, A, B, and C. They show the stopping distance of the same car. Okay, so we've got different stopping, different braking distances. Brilliant. On different days, the car travels along the same road at the same speed. The stopping distance from the journeys are shown in diagrams A, B, and C. So we know it's the same car, same speed, same road, maybe different road conditions though. Okay, so name two factors that might have caused the increase in stopping distance shown between diagram A and diagram B. There's loads and loads of options here. Yeah, so you just got to think what's going to increase the braking distance. Because if you notice, the thinking distances are both the same, whereas the braking distances are different. Okay, so what has caused the braking distance to increase? So if you said something like drinking or taking drugs, then that's probably, well, that's not going to get you a mark because that would increase the thinking distance. We're looking at just braking distance. Okay, so loads of different ones. You could have wet road. You could have poor brakes. Let me just get the pen up. You could have increased mass, so a heavier car, so they've got a bit of a load in there. You could have snow, you could have leaves, like anything that's going to increase that braking distance. Although they only want one of the conditions on the road, and then the next one they want like faulty brakes or increased mass, that kind of stuff. So first, 2 marks, nailed down. Third mark, name one factor that may have caused the increase in the stopping distance shown between diagrams B and C. So what you can see on diagrams B and C, look, braking distance is the same this time. The difference is the thinking distance. So just like I said at the start, we can start thinking about what's going to cause an increase in thinking distance. The most obvious one is alcohol, yeah? But you can also have drugs, tiredness, illness, lack of concentration, distractions, your age, your reaction time, all those different things would also get you a mark. So there's loads of options here. If you just put something down, you're probably going to get something. Okay? On to part B, sorry. So the speed of the car doubles. How does this affect the thinking distance and the braking distance? So if the speed of the car doubles, we know that the thinking distance is going to, what's it going to do? It's going to double as well. Okay? So speed doubles, thinking distance doubles. You're going to travel twice as far in the same amount of time. However, what you always have to remember, what's going to happen to the braking distance? The braking distance is going to quadruple, okay? The reason for this, okay, is quite a complicated reason, but if you think of the equation for kinetic energy, then you'll start thinking half mv squared, so half mass times velocity squared. Okay, if you notice, your velocity is squared, okay? That squared basically means that it's going to be 4 times harder to stop a car, the same car traveling at twice the speed. Okay, don't worry too much about that bit about kinetic energy. Okay, the main difference is the fact that you remember that thinking distance is doubled, braking distance is quadrupled. So drivers are encouraged to drive slowly down steep hills. Suggest why drivers are encouraged to drive slowly down steep hills. So why would people try to stop you driving quickly down a steep hill? So, only 1 mark, so really straightforward. So you could have, if you're going slower, means you can have a shorter stopping distance. It's literally as simple as that. It's like stating the obvious, isn't it? You could also have that you're less likely to skid, you're less likely to lose control of the car, all these different things. So that's basically your 1 mark in there. Moving on. So here's our 6 marker. Again, like I said with the other 6 mark questions, we're going to go and do them in a separate video, or we might just do them in class, if I'm honest. It's a kinetic energy one. We'll talk about it another time. Moving on. So there's different types of speed cameras. One type of speed camera is called an average speed camera. The 2 cameras work together using infrared beams. Okay, both cameras record the time when a car passes through the infrared beam. Describe how average speed is calculated using camera A and camera B. Okay, so really easy. You could just put the speed equation there. Okay, let me get the pen. Speed equals distance over time. Obviously put words in rather than the letters because you won't get a mark for that. But basically what they do is that they know the distance between the cameras and they divide that by the time that it takes. So they know the distance from here to here. They just need the time that it takes to get from there to there, and they can work out how fast that car is going. The speed of the car at camera A is 12 meters per second. The car decelerates at a constant rate. The time it takes for the car to travel between cameras A and B is 2 minutes. The distance between the cameras is 1,200 meters. Calculate the speed of the car at camera B. Okay, this is tricky, guys. So what you need to do is you need to use one of your equations from the front of the book. It is the S equals U plus V divided by 2 times T equation. Now, lots and lots of information there, okay? So S, U, V, and T we've got going on. So S is our distance, U is our initial velocity, V is our final velocity, and T is the time. So if we have a little think, we want to find out, it's said in the question, calculate the speed at camera B, which is our final velocity, so there's our question mark. S is the distance travelled, which we know is 1,200 meters. U is our starting velocity, which is meters per second, 12. And T, time, it's given us it in minutes because they're sneaky. We want it in seconds, so it's 120 seconds. Now you substitute all that in. So you got 1,200 equals 12 plus question mark divided by 2 multiplied by 120. Gone off the page. It is there, trust me. Let me move it over a little bit. 120. Okay, if you work all of that out, you should end up with 8 meters per second to get the full 3 marks. Okay, if you're having any issues with that, please come see me. It is a really complicated question, but with a little bit of thought, just like always, a little bit of thought, you can do that one really easily. So, last bit of this page, a car with double the average speed travels along the road. Explain what happens to the time recorded by the speed cameras. Okay, so 1 mark. If you say it takes less time, you only get 1 mark. Okay, if you try to explain how much less time, if you say it takes half the time, or you actually say literally 1 minute, you get the 2 marks. Okay, so it's all about quantifying it as well as telling them what's happening. So, look at the picture of the solar-panelled car. On we go. Solar-powered cars may lead to an overall reduction in carbon dioxide emissions. Look at this statement. Solar-powered cars reduce pollution, but they also produce pollution. Explain how solar-powered cars can reduce and produce pollution. So, obviously, we're thinking you should be looking at this question. 2 marks. They want 1 point for reduce and 1 point for produce. So, just make sure that you're using both of them. So the first mark is that if it does, you just say that it doesn't use fossil fuel. Okay, that's 1 mark there. The second one is the fact that they produce, so they don't use fossil fuels, that's the reduce bit. The produce bit is that carbon dioxide is made in production. So when they make the cars themselves, they produce carbon dioxide. Okay, so the whole process of actually making those. So there's your 2 marks. Solar-powered cars race across Australia. Explain how technology can be used to increase the top speed of these cars. In your answer, consider the risks and benefits this has to drivers, okay? So that's quite a meaty question for just 2 marks, okay? So the first bit you need to address is how we're going to increase the top speed of the cars. The second bit, you need to think about how this risks or benefits the driver. So the first marking point for this has to be a feature and a reason. So you could say, make them more streamlined, but that will not get you a mark. You need to give it a reason why that is going to increase the speed. So if we talk about streamlined, we need to say that we're going to reduce drag, yeah? So we're going to decrease drag. Or we could say reduce the friction. We could say lightweight, but then we need to give a reason why, okay? So to reduce the energy required to do work. You could say increase the efficiency of solar cells, but then you need to quantify it by saying so there's a greater energy transfer. So you need to give a reason and a feature and a reason. The way that we know that is because it says explain, okay? It says this word explain, how technology can be used. So explain, you generally need to give a feature and a reason. That's only 1 mark. The second mark is this bit down here. It's the risks and benefits this has for drivers. So you could go for the higher speeds side of things. So at high speeds, more risk of causing greater injury. So that would get you the second mark. High speed equals increased risk. Okay, second one done. All right, well done. Blank page, and here we are. Right, so another weightlifter. They love the weightlifters in this paper. So she lifts 6 different weights. The plots on the graph show the distances she lifts each weight. So we've got various different weights in newtons along the bottom, and then we've got the distance she lifts those weights in meters. Okay, fantastic. So we move on to the next page where he'll be asking us some questions about it. Okay, so the first question is the speed she lifts the weight shows how powerful the lift is, which is Deng's most powerful lift. So we have a little look. We can see that E and F have got the shortest amount of times. But if we move back to the other page, we'll also notice that that F is actually the heaviest and the furthest that she's moved it. So that clearly shows that the most powerful lift is obviously going to be F, especially because the distance has been moved, is the greatest. Use the graph in the table to help explain your answer. So you've got the 1 mark for identifying F, but then you also have to back it up with some information. So you could put in the lift, the greatest force at the greatest distance. So like I said, from the graph, you could say the greatest force, or greatest force, because it's around about 750 newtons, for the greatest distance. The second, also the third mark for this one, is going to be when you say when the work is done in the shortest amount of time. So we looked at it, we could see that these two are the shortest amount of time, so that obviously gives us the other clue as to when the most work is done. You could calculate the work if you wanted, but I mean there's no need to. So if you just said work done in the shortest amount of time, job's a good one, yeah? So it's an M. So it's 3 marks, easily done. There's nothing massively complicated. The thing is, with all these different things, you've got a graph, you've got a table, you've got some person lifting weights. They're trying to confuse you again, yeah? They're trying to mess you up. Just stay focused on exactly what it's asking you. All it is asking you is which is Deng's most powerful lift. That is it. That is the question. That's what you need to answer. So don't get bogged down with all the other stuff. That's the last part of June 2014 higher tier, guys. The physics. I hope it's been useful. As always, any questions, come see me, and stay classy.